Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 6, Section 1, Quadratic Functions. We started the notes by getting a page that may look familiar to you from Algebra 1, and it was all about taking parabolas as the parent equation, y equals x squared, and if you remember, we had it on a graph, and the parent equation was written in a dotted line, and we started with y equals x squared, and we graphed that, we traced over this, and then we took this parabola and we did translations with it. First we flipped it upside down, so we did some trial and error, got our calculator to display it like this, and so on. We moved it up and down, left and right, thinner, made it a skinnier parabola, and a fatter. So please get that page from me if you need help completing it. This was very important as the start of our 6.1 notes. When we were done reviewing the translations of the parabola y equals x squared, we reviewed some terms that you also did learn in Algebra 1. Remember, the domain is all the x values. The range represents all the y values on the graph, and we need to know how to identify these. We're going to be doing a lot in this chapter with finding the x-intercepts. Not so much in Section 1, but later on we will. I do want to review finding the y-intercept. This is the thing that students forget the most. The x-intercept, of course, is where the graph crosses the x-axis. And, of course, there may be more than one. If you have an x squared, a quadratic, there's going to be sometimes 2 times where it crosses the x-axis. If you have an x to the third, there could be 3 x-intercepts. The y-intercept, very often you need to find this algebraically because your calculator doesn't help you with it too much. The y-intercept is where the graph crosses the y-axis, and sometimes there's more than one, but in the ones we're doing in this chapter with the parabola, there's just going to be one. So please write this down. To find the y-intercept, you put however many x's there are, you set them all equal to 0, and you solve for y. So if you're not writing down anything else from this screen, write this down. You need to know how to find the y-intercept. The definition of a vertex is where the graph changes directions. It is a minimum if the parabola is right side up like this. The vertex is here, a minimum value. If it's an upside down parabola because of the negative, then this vertex is a maximum value. And know how to find those on your calc, and we're also, in the next section, we'll find them using the vertex form of the equation. The axis of symmetry, you need to know by definition, this is the line that cuts the parabola into 2 mirror images. In other words, it cuts it in half. So we're going to need to know how to draw in this axis of symmetry as I make perfectly straight lines here. Yeah, sorry about that. And we need to draw it in, and then we need to find the equation of it. So know these definitions. Some other things you need to know. If we write a quadratic like this, you remember we did this when we were learning quadratic formula. I told you to put the equation in standard form before you found the a, b, and c. So we're just reviewing that when it's written with the x squared term first, and then the x term, and then the constant, this is called general form or standard form, and you need to know both of those terms. We're going to have to be able to move from the general or standard form into vertex form and vice versa. And then just some terms, what we call it. We call the x squared term the quadratic term. We call the x term the linear term. And of course the c is the constant, or just the number. I'm not sure what you need from this screen. I was just trying to be very clear, and I was summarizing what we did on the parabola worksheet where we were doing the translations. The a, the x squared coefficient, has an effect on the graph. we learned that if a is positive, the parabola opens upward, like this. If the a is negative, the parabola opens downward. If a is greater than 1, like 2, 3, 4, 5, it makes the parabola thinner. Now, one thing you do have to note on this screen, I used the word thinner or narrow. Your book uses the word steeper. Please note that all these mean the same thing. They're just saying that it goes up at a steeper slope, if you will. And then if a, the absolute value of a is less than 1, that is if a is a fraction. Okay, I'm not saying that it's negative. I'm saying that the absolute value is smaller than 1, like a fraction, 1/2, 1/3. This makes the parabola get wider, fatter. Your book uses the word flatter. So the parabola opens up wider like this. And I think they say flatter because they're kind of squishing it. So please know those terms. And of course, we learned that the number, if the number is positive, it moves the vertex up. If that number is negative, it moves the vertex, the whole parabola, up or down. So again, this is just a summary of that page from your notes that was a review of Algebra 1. All right, let's look at an example. Now you can tell by reading the directions, I put a lot into, I dumped everything into one example so we could just do this and be done. We are asked to find the domain, the range, the y-intercept, the vertex, the equation of the axis of symmetry, minimums, maximums, and then we have to describe how it compares to the parent equation. So this is our quadratic. We're going to use a combination of our algebra skills and our calculator. So I graphed this on my calc and then I sketched it over here the best that I could. So we have to start somewhere. Now I know that knowing the vertex is going to be very helpful. The vertex will help us with domain and range and axis of symmetry. So we're going to learn later on this chapter another method to find vertex, but for today let's use our calc. So this is what we're after, this is the vertex, which happens to be a minimum in this graph. So if you went to the second calc and you selected minimum, and then you did the left bound and right bound, you got to realize your calc is displaying pixels and it's not the best. Your calc might say that the x of the vertex, for instance, it might say negative 0.4999999, okay? We have to realize that the pixels are affecting the display here and that the x value of the vertex is really negative 0.5. So if you wanted to say it that way, you could. If you like fractions, you can say negative 1/2. And then we look at the y display here of this minimum value. And again, it might be a long decimal, but what the calc is really trying to say is it's negative 3.5. Again, if you like fractions, you could say negative 7/2. So I'll check that off our list. We have found the vertex. Now let's use that. That is very helpful in finding domain and range. So the domain of this. So your eyeball is going back and forth, looking this way, and I'm not sure if my picture looks like it, but this parabola does keep on going in both directions here. It's getting wider and taller at the same time. So there is no limits as we look back and forth on the x, on the domain. So the domain is all real numbers. But the range, however, we do have a limit. This parabola doesn't exist down here as we get below a certain point. So we're going to say range is the set of all y's such that y, now we look right here, that's the lowest that this goes, and we know this point. This point is the vertex. We're down here, we're down at negative 3.5. The parabola only exists above that. So I would say that y is greater than, and it includes the vertex, so it's greater than or equal to negative 3.5. The other thing that the vertex is very useful so that we can write the equation of the axis of symmetry. Now the axis of symmetry is a line. I'll draw it here. If I can draw a straight line, that would be awesome. It's cutting the parabola into two mirror images, and it passes, you'll notice it passes right through the vertex. This cuts it in half, and from our review of Algebra 1, we know that a vertical line has an x equals equation. And so you need to figure out, what does x equal? Well, if it passes right through the vertex, then this x value, this x coordinate of the vertex, is where this line lies. So the axis of symmetry can be expressed by the line y equals, if you like fractions, you can write -1/2, or you could just write, I think I said y, sorry, or x equals -0.5. Either one of these is fine to express the line of the axis of symmetry. So let's check off what we've done here. We've done domain, range, vertex, axis of symmetry. We did the minimum, which is the vertex. This graph keeps going in the positive direction. It has no maximum values. So what we have left here is the y-intercept, and to state how it compares to its parent equation. So the y-intercept, we learned in our review that that is where x equals 0. So it doesn't matter how many x's there are. Put a 0 right in for that x, a 0 in for that x, and then the y would equal, that's gone, so the y is -3. So the actual intercept, well, you can kind of look here, 0, I guess I didn't do too bad, it should cross right there. So the y-intercept is the ordered pair 0, -3. Now we need to state how it compares to the parent equation. So thinking back to that first page we did, again, the review from A1. So the comparison, first thing I noticed, because of this 2, this is narrower. You could call it steeper or narrower, whatever. So it's narrower. The other thing we did from the parent equation, like if I just draw it in with dotted lines, this is sort of the parent equation. It is slid over to the left, and we went to the left 1/2 or 0.5. I don't need to say negative because I just said left, but you could. And then we shifted this down 3.5 units. So this right here is the description. This is the comparison to the parent equation. So now you have the knowledge you need for section 6.1, so have fun with math.